Hi guys, how you doing? I hope you're keeping safe, I hope you're washing your hands. And yeah, so here I am on my own in an empty classroom, that's why you've got all the echo. Taking a risk for you, just for you. I'm not staying home, I'm coming to school and getting ready to teach. So, today I want to talk about upper quartile, lower quartile and interquartile range. Okay, so just to refresh your minds, how many averages should you know? And if you're thinking that the answer is 4, you are very wrong, because there are only 3 averages: mean, median and mode. Remember, the range is not an average. How many times did we repeat that? Yeah, the range is not an average. What's the range? We said the range was a measure of dispersion, okay? It measures how wide apart or how bunched up together our data is. Today, I want to talk to you about the interquartile range, which is another measure of dispersion. I might do a second video giving you the theory why we calculate and why we need it, so you understand. This video, I'm just going to talk about the mechanics of finding the interquartile range, okay? So, here I've got 11 data points. I've got 11 numbers, okay? And I need to find the median, the upper quartile and the lower quartile. Now, if you remember, we did this before the holidays. To find the median point, you do total numbers, so how many numbers have I got, plus 1 divided by 2. So if we do that, the median point is going to be total number of data points that I've got, 11, I've got 11 numbers, plus 1 is 12, divided by 2 is 6. So the median point is data point number 6. It doesn't mean that the median is 6. It means that the median is data point number 6. So I'm just going to count 1, 2, 3, 4, 5, 6. That there is the median. Okay? So this shouldn't be causing anyone any breakdowns. I shouldn't be having any heart attacks, people. We're just finding the median. We've done this before. Okay? Okay. Right. Now, the median, what it does is it splits the data in 2 equal halves. I've got 1, 2, 3, 4, 5 data points here. I've got 1, 2, 3, 4, 5 data points the other side of the median. I've split my data in half, median in the middle, right? Okay, cool. Now I need to find the lower quartile. Sorry, I might as well sit down so you can see my beautiful and shaven face. The lower quartile, what it does is we're going to look at only the first half of my data set, so from the first point up to the median, and we're going to split that in half as well. So, to find the lower quartile point, to find which data point is the lower quartile, I do total plus 1 divided by 4, okay? So the total is 11, plus 1 is 12, divided by 4 is 3. So the lower quartile point is the third data point. So, if I just count now, 1, 2, 3. That number there is the LQ for lower quartile. Okay? So, first, I split the data in 2 halves. Then I take that first half, split it into 2 equal halves, because I've got 2 data points there and 2 data points there. And now, I'm going to find the upper quartile. I'm going to take the upper half of my data and I'm going to split it in 2 as well. So to find the upper quartile point, I do n plus 1, so the total number of data points, which was 11, plus 1 is 12. 12 divided by 4 is 3. 3 times 3 is 9. Or if you prefer, 3 multiplied by 11 plus 1 divided by 4. So 3 times 12 is 36. 36 divided by 4, 9. So the upper quartile point is data point number 9. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the UQ, the upper quartile. So as you can see now, what we have achieved is that we have split our data set into 1, 2, 3, and 4 equal parts. Okay? That's why they're called quartiles, because they split the data into quarters. Who would have thought, right? This is beautiful, by the way. I don't have to listen to Pablo Galvis making any funny comments. I don't have to see Carlos sleeping at the back of the room. I certainly don't need to hear Carla, Maria, and Esther talking all the time. And Carla, you're chewing gum, aren't you? Anyway. So, this is it. Once I've got the upper quartile and the lower quartile, I can find what is called the interquartile range, the interquartile range, and that literally is a little bit like finding the range. But instead of doing highest take away the lowest, to find the interquartile range, you're going to do the upper quartile take away the lower quartile. What's my upper quartile? It is here, 125. So 125 take away the lower quartile, and the lower quartile is 70. So, if my math don't fail me, which they might do, 55 I want to say is the answer. So the interquartile range is 55, okay? Interquartile range, 55. Means I've got a difference of 55 between the bottom quarter, or the bottom 25% person and the 75% person. Okay, I don't want to make the video too long. I'm just going to talk a couple of things theoretically why we do this. Why do we find the interquartile range? You may, I don't know if they will ask you this in the exam, but you should know, okay? So, the problem with the range, highest take away lowest, is that if you got an extreme value either at the bottom or at the top, and I try to find the range, that number, that range is going to be distorted if I have a very high number or a very low number. For instance, say I do a survey of how much people get paid at school, teachers, how much teachers get paid at school, and I include myself, Miss Pierce, Mr. Oakley, I don't know, Miss Almenara, whatever, and then I ask Mr. Corby, what's going to happen with the range? It's going to be a huge difference between the lowest paid person there, me, and the highest paid person there, Mr. Corby. So, what you can see is that by doing the interquartile range, I take the bottom 25% person there, I don't know who that might be in the school, but probably one of the normal teachers, and person, the upper quartile, the person 3/4 of the way to the top. Who could be 3/4 of the way to the top? I don't know, Mr. Kelso, right? So I'm not going to get that big a distortion there. And the interquartile range looks at the middle 50% of the data. It doesn't look at the top 25% of the data. It doesn't look at the bottom 25% of the data. It looks simply at the most representative 50% of the data. It looks at only half of the people, but the half of the people that are in the middle. So it gets rid of the extremes, and it only looks at the 50% of the people that are in the middle, because they are the most representative person. Mr. Corby isn't really the most indicative person of how much money you can make if you go into teaching. That sort of makes sense, right? Okay. So this is how to find the upper quartile, lower quartile, and interquartile range when we've got an odd number of data points. My next video, I will explain how to find it when we have an even number of data points, and it is no different, but I just want to give you an example of it. So please watch this, make sure you've understood it. You can copy the example out in your books. You've got it all here. I've gone through it. Yeah, and check on Classroom, because I will give you what work you need to be doing next. All right? Good. I'll see you in a few minutes. Please take care. Wash your hands. Carla, chewing gum in the bin. Carlos, wake up. Sorry, I just missed that sort of thing. I miss you guys. Not really. Bye.